Our group name was Vox Perfecta, which means perfect sound. We did the 3D printing project, and this is by Sophie Backhouse, Katie Cross, Nate Davis, and Paul Gartman.
For our project, we utilized the engineering design cycle. The steps include identifying our problem, identifying our constraints, generating some ideas, exploring possibilities, research, and select an approach. Our problem was to 3D print an object for vacation use, and constraints included a $40 budget, maximum size per part will fit inside of a 6-inch cube, and the product must have at least 2 distinct functions. Ideas we generated were a fidget spinner, a speaker with charging capabilities, a USB with an attached whistle, a functional Thor's hammer with screwdriver, or a flashlight with a screwdriver. We explored these possibilities and found that the flashlight with the screwdriver was too mundane. The functional Thor's hammer and fidget spinner were more of novelty ideas, and the speaker would have been out of reach with our budget and previous knowledge. The USB whistle fit perfectly within our budget and we found to be extremely useful.
3D printing is a cheap, effective way of manufacturing and prototyping small models. These qualities make it extremely applicable to the production of whistles. Not only could we print different versions of the same design, but we could also test out different design strategies concurrently. 2 designs we explored were P and P-less whistles. P whistles feature a gyrating ball agitating the air within the cavity of the whistle, whereas P-less whistles do not. We set about designing a whistle that could be attached to a keychain and featured both a USB thumb drive and safety whistle. This would allow students to remain safe and prepared during vacations and academic excursions. Use of fast-setting filament to form intricate shapes, such as a resonating chamber, demonstrates the unique capabilities of 3D printing for solving engineering challenges. Originally, we started modeling our project with a software called Tinkercad. After several SketchUps, we transferred our design over to Autodesk Inventor and completely redrew our resonance chambers. From there, we adjusted our design to produce the pitch, tone, and strength of sound we wanted. During our project, we went through 7 design iterations, modifying the cavities and wind channels of the whistle. Due to having so many prototypes, the majority of our material expenditures came from used filament. As we became more familiar with the modeling software, we began to employ techniques that allow us to reduce both the print time and amount of material used.
For our final product, we chose to use a white filament to create the whistle and USB holder. This causes the USB to light up when plugged into the computer. The next component we used was the 16 gigabyte USB storage drive, but this can be customizable depending on the customer. Next, we have the safety whistle that, as stated before, can be used on vacation, which was what our problem was, or it can be even used daily for college. Next, we have the lanyard and keychain component that makes it so you cannot lose it easily, which is very important. For this project, we had 2 design challenges: how to insert the USB and get it to stay, and how to make the whistle functional. For how to insert the USB, we had to take the dimensions of the USB and then take the dimensions of our product and make it larger so the USB can snugly fit in. The other problem with this was what type of glue we had to use to make sure the USB stays in and doesn't fall out. The 2 choices were hot glue and Gorilla Glue. We chose to use Gorilla Glue over hot glue because hot glue creates a mess and is less professional. For how to make the whistle functional, we had to research the principles influencing pitch and then redefine the tolerances of the wind channels to reflect our goal of producing a loud and piercing tone.
Some questions you may have for us. How much did we spend on our project? We spent $10 on a USB, $20 on filament, which was utilized for over 7 prototypes. How did we place in the competition? We tied for first with a total of 95.5 points. What would you do differently? If we were to do this differently, we would have changed the dimensions for the keyhole on the top to make the plastic part smaller. This would allow our device to be placed on a keychain or lanyard with greater use. We would have also engraved our whistle to make it more customizable for the user. So some advice to next year's freshmen. Don't be afraid to delve into the unknown. Picking a project can be a scary and intimidating task, but don't be afraid of that, as it will make you more comfortable in the future for other projects. The first step is always the hardest. Picking your project and starting it will always be very challenging, but once you get the ball rolling, it's much easier to finish. The meaning of life is within you. This is a good quote to live by, and make sure you pick a project that is meaningful to you. That way it will be more enjoyable. Pick something unique and be an outlier among your contemporaries. The main reason we won was because we went in a very different direction from everybody else. If you're different than everybody else, it is much harder to compare you to them. To improve is to change, so to be perfect is to have changed often. This is a quote from Winston Churchill. This is also a good quote to live by, and it applies to the project. It took us 7 times to finalize our design. Mistakes are just part of life. Start and finish your project early for minimal stress. We finished a week early, and it was very relaxing while everybody else was stressing out. Make sure to sell your project to the judges. Our project looks very underwhelming, but upon closer examination and saying all of the various uses for our project, many minds were changed. Some food for thought. Don't be the world's tallest dwarf.